Okay, in the last class we discussed about the linear systems. What is linear system? Properties of linear systems, right? Okay, impulse response, transfer function of LTE system, linear time invariant system, its properties of LTE systems, okay, etc. Okay, and also we are doing some problems also. Already we have done some one or two problems. Okay, we continue the problems. Okay, so we will check the causality, invertibility, linearity for this problem also. Okay, now we will see this problem. The signal has an impulse response h of t equal to 4 into e power minus 4t into u of t. Find the graph and response of the system to x of t equal to rectangular of 2 into t minus 1 by 4. Okay, so it is a system having the impulse response h of t is given as 4 into e power minus 4t into u of t. Okay, we have to find the graph and response of the system to x of t, that is the x of t is nothing but rectangular of 2 into t minus 1 by 4. So the impulse response of the system is given as h of t equal to 4 into e power minus 4t into u of t. U of t is given in the sense it is varying from 0 to infinity. So its waveform is like this. H of t is 4 into 4 is nothing but its amplitude or magnitude. So 4 into e power minus, it is exponentially decaying function. So it is 4 into e power minus 4t, right? So the input signal x of t to the system is given as x of t equal rectangular function of 2 into t minus 1 by 4, or it is 2t into 1 by 2. Rectangular of 2t into 1 by 2. So it is as shown like this. X of t equal to, it is rectangular function of 2t into 2t minus 1 by 2. So it is as shown like this. Okay. Okay. So then the response of the system can be obtained as y of t, response y of t equal to x of t convoluted with h of t. So r in the formula we can write this as integral minus infinity to infinity h of t into x of t minus k dk, right? H of t into x of t minus k dk, right? H of k and x of k signals are shown in the below diagram. So this is h of k and this is x of k. Only thing is t is replaced by k. So the time reversal form of x of k is x of minus k. That is the mirror image of x of k. Is represented as shown like this. So it is represented from minus 0.5 to minus 0.75 to minus 0.25. So it is a mirror image. So it is 0.25 to 0.75 with amplitude 1. Okay, this is the mirror image of x of k. That is x of minus k. Okay, so for t is less than 0, the signal x of t minus k can be represented as shown in the figure. X of t is already there. So x of t is this one. X of t minus k can be represented like this. So for t is less than 0, the signal x of t minus k can be represented as figure 6. Then k equal to 0 to 0.75 to t, from here to here. If k is from 0 to 0.75 plus t is the time period over which both x of t minus k and h of k are present. So h of k is present from 0 to infinity. So this is 0 to 0.75 plus t is x of t minus k is also present. Okay. So then y of t equal to integral 0 to 0.75 plus t. So integral e power minus 4k into dk. 1 point, e power minus 4k into dk. Okay, it is 1 into 1 means its amplitude is 1. 1 into 4 into e power minus 4k dk. Okay, x of the value is h of the value is h of the value is 4. 4 into e power minus 4k, and its value is its amplitude is 1. So 1 into 4 into e power minus 4k into dk, or it is 4 by minus 4 into e power minus 4k limits 0.75 plus t to 0. So it is minus 1 into e power minus 4 into 0.75 plus t minus e power 0. Okay. So it is e power minus 3 into e power minus 4t. E power 0 is 1. So its value is 1 minus 0.04 98 into e power minus 4t. That is, let it be considered as equation number 1. Then from t equal to 0 to 0.75 to t. For t is greater than 0, the signal x of t minus k can be represented as shown like this. For t is greater than 0. For t is less than 0, it is as shown like this. For t is greater than 0, it is shown like this. Okay, so k is varying from t plus 0.25 to t plus 0.75 is the time period over which both x of t minus k and h of k are present. Okay, hence y of t equal to integral t plus 0.25 to t plus 0.75, and this is this value, this amplitude is 1 into 4 into e power minus 4k dk, or it is 4 by minus 4 into e power minus 4k with the limits t plus 0.75 to t plus 0.25. So it is e power minus 4 into t plus 0.75 minus e power minus 4 into t plus 0.25. Okay, so by simply uh, simplifying this e power minus 40 into e power minus 1 minus e power minus 3. So it will become e power minus 40 into e power minus 1 minus e power minus 3 for t is greater than 0. So its value is 0.318 into e power minus 40 for t is greater than 0. So this is question number 2. Earlier one is for t is less than 0, y of t value. So for t is equal to 0, x of t minus k is equal to x of minus k, which is as shown in the figure 5. Figure 5. So this is this one, this one. So for t is equal to 0, right? So t is equal to 0, this is the figure. For the values 0.75 to 0.25 to 0.75, the signal x of t minus k and h of k both exists. So it is 0.25 to 0.75, 1 into 4 into e power minus 4k dk. So it is 4 by minus 4 into e power minus 4k into e power minus 4k with limits 0.75 and 0.25. So by simply substituting, we can get y of t value is 0.318 for t equal to 0. That is equation number 3. So now y of t equal to, this is t is less than 0. This is the value for t is less than 0. This is the value for t equal to 0. This is the value for t is greater than 0. So the response y of t for all the cases is as shown like this. For t is less than 0, it is exponentially growing from 0.75 to 0. For t is greater than 0, it is exponentially decaying from 0 to this value, 0.25 value. If it is t equal to 0, its value is 0.318. So this is the response of y of t for all cases. For t is less than 0, t equal to 0, and t is greater than 0. So this is about this problem. That is the figure 8. Okay. Next we'll see the next problem. Find the transfer function of lattice network shown in the below figure. Transfer function of the lattice network. Lattice network. So it is lattice network means it is the combination of inductors, capacitors, and resistors. These are connected uh, in a systematic way like this. So this is called lattice network. Lattice network, and the input signal Vi of t and the output signal V naught of t. Okay. So having the inductor having the value 1 henries and the capacitor having the value 1 farad. Okay. Okay. Vi of t is the input of the circuit, V naught of t is the output of the circuit. Okay, so here the potential across the points, let it be, uh, let us consider the points. This is A and this is B and this is C and this is D. Okay, the potential across the points A and B is similar to potential across the points C and D. The potential or voltage across the points A and B is similar to the potential across the points C and D. Potential across A and D is similar to potential across the points B and C. Okay, so write the equivalent circuit of this one. So it is like this. compare it. One, one, this is a this is one, so that we have two loops will be formed. Two loops will be formed. Let I1 and I2 be the loop currents. I1 and I2 be the loop currents. So now applying Kirchhoff's voltage law to loop 1. Okay, Kirchhoff's voltage law to loop 1. So VI of T is equal to 1 into, this is a capacitor, this is inductor. So 1 into d by dt of I1 plus 1 by 1 by L, that is 1 by 1 into I1 minus I2, I1 minus I2 into dt plus 1 into d by dt of I1. For loop 1 we are applying KVL. Okay, so this is the equation we will get. Okay, that is 1 into d by dt of I1 plus 1 by 1 into I1 minus I2, I1 minus I1 minus I2 into I1 minus I2 into dt plus I1 minus I2 is capacitor. So plus 1 into d by dt of I1 is equal to VAR. Taking Laplace transform of equation number 1, we will get VA of S equal to S into I1 of S plus I1 of S by S minus I2 of S by S plus S into I1 of S. So taking I1 of S as common, so that it will become 2S plus 1 by S minus I2 of S by S. That is equation number 2. The same manner we will apply KVL to the loop 2. KVL to the loop 2. So KVL to the loop 2 is so here in voltage 0 is equal to 1 into I2 E2 plus 1 by 1 into I2 minus I1 into D. That is equation number 6. In the same manner, we are taking Laplace transform of equation number 3. We get 0 equal to I2 of S equal to I2 of S plus I2 of S by S minus I1 of S by S. So taking I2 of S as common, 1 plus 1 by S minus I1 of S by S, or I1 of S by S is equal to I2 of S into S plus 1 by S. Okay, so I1 of S equal to I2 of S into S plus 1, that is equation number 4. Therefore, the output voltage V0 of T is given by V0 of T equal to V0 of T equal to 1 into I2. That is resistance value I, resistance value R equal to 1. That is 1 into I2. Apply Laplace transform so that V0 of S equal to I2 of S. Okay, that is equation number 5. So substituting equation number 5 in equation number 4, why? Because I2 of S equal to V naught of S. Okay, so instead of I2 of S, I replace V naught of S. So I1 of S will become V naught of S into S plus 1. That is equation number 6. On substituting equation number 5 and 6, both equations in equation number 2. What is equation number 2? This is the equation number 2, VI of S. So that we will get VI of S equal to V naught of S into S plus 1 into 2S plus 1 by S minus V naught of S by S. Okay, or V naught VI of S equal to taking V naught of S as common into S plus 1 into 2S square plus 1 by S minus 1 by S, or taking LCM as S, so that it will become 2S cube plus 2S square plus S plus 1 by S minus 1 by S. So will become 2s square plus 2s plus 1 into v naught of s. Okay, so r vi of s equal v naught of s into 2s square plus 2s plus 1. R vi of s by v naught of s is 2s square plus 2s plus 1, or v naught of s by vs of s. Vi of s is equal 1 by 2s square plus 2s plus 1, or v naught of s by vi of s is nothing but the transfer function or system function, that is h of s, which is equal to 1 by 2s square plus 2s plus 1. Okay, so this is about the this next problem, lattice network problem. That is the transfer function. So transfer function h of s equal to 1 by 2s square plus 2s plus 1. Next problem is sketch the magnitude and phase characteristics of h of j omega. Sketch the magnitude and phase characteristics of h of j omega. Okay, so what is the given problem here? See here, see the above transfer function, that is h of s, replace j omega by s, that is h of s equal to 1 by 2s square plus 2s plus 1. Okay, so s equal to s equal to j omega, so that h of j omega equal to 1 by 2 omega 2 j omega square plus 2 into j omega plus 1. Okay, that is 1 by j square is minus 1, so it is minus 2 omega square plus j into 2 omega plus 1. So our we can separate the real terms and imaginary terms. So 1 by 1 minus 2 omega square plus j into 2 omega. Now rationalizing this denominator, we get 1 by 1 minus 2 omega square plus j 2 omega into 1 by 2 omega square minus j 2 omega by 1 by minus 2 omega square minus j 2 omega. Okay, it will become 1 minus 2 omega square minus j 2 omega by 1 minus 2 a, this is a plus b into a minus b form, so that is a square minus b square. So 1 minus 2 omega square whole square minus j 2 omega whole square. So j square is minus 1, so minus 1 to minus will become plus, so 4 omega square. So it is 1 minus 2 omega square minus j 2 omega by, this is a minus b whole square, a square minus b square plus 2 a square plus b square minus 2ab. Okay, right. So it is 1 plus 4 omega power 4 minus 4 omega square plus 4 omega square. So 4 omega square minus 4 omega square gets cancelled, so that it will become 1 minus 2 omega square minus j 2 omega by 1 plus 4 omega power 4. Okay, so h of j omega is equal to 1 minus 2 omega square by 1 plus 4 omega power 4 minus j 2 omega by 1 plus 4 omega power 4. So we have to calculate the magnitude and phase angles. So magnitude, taking the mod of which of j omega is equal to square root of a square minus a square plus b square. So 1 minus 2 omega square whole square plus 4 omega square by 1 plus 4 omega power 4 whole square. So it will become 1 by 1 plus 4 omega power 4 into square root of 1 plus 4 omega power 4 minus 4 omega square plus 4 omega square. So these two will get cancelled. So it will become 1 plus 4 omega power 4 whole power 1 by 2 by 1 plus 4 omega power 4. So this magnitude mod which of j omega equal to 1 by square root of 1 plus 4 omega power 4. And coming to the phase calculation, angle of h of j omega is equal to tan inverse of minus p by minus imaginary term by tan inverse of imaginary term by real term. So imaginary term is minus 2 omega by 1 plus 4 omega power 4 by real term is 1 minus 2 omega square by 1 plus 4 omega power 4. So it will become tan inverse minus 2 omega by 1 minus 2 omega square, or tan inverse omega 2 omega by 2 omega square minus 1. Okay, for this we have to draw the magnitude and phase spectrums. Okay, so magnitude spectrum for taking the omega values as minus 3, minus 2, 1, minus 1, 0, 1 to 3, for these values substitute the omega value in this expression so that the mod h of j omega will become 0.05, 0.1 to 0.25, 1, 0.45, 0.1 to 0.05, so that the magnitude of that mod h of j omega versus omega uh, will be like this. By drawing the magnitude plot, it will be like this. In the same manner, phase plot also, you can draw the phase plot. Okay. Which omega versus angle of which of the omega. So these are the angles 19.44 degrees for minus 3, for minus 2, minus 29.74. Okay. For minus 1, it is minus 33.9. Okay. Like this. Okay. Like this, we can draw the phase plot. That is about the magnitude and phase plots of the given problem. And problem is find the current I of t in a series RLC circuit as shown in the figure, and a voltage of 100 volts is switched on across the terminals A dash, A dash. So here 100 volts is switched on across the terminals A dash at t equal to 0. T equal to 0. We have to find the current I of t in a series RLC circuit. In a series RLC circuit. Okay, so given switch is closed at t equal to 0. Okay, t equal to 0 means it is closed. Before t equal to 0, at t equal to 0 minus, there is no flow of current through the circuit. At t equal to 0 minus, there is no flow of current through the circuit. Hence, the initial conditions of the circuit is, these are the initial conditions. So, initial conditions of the circuit is 0 initially. After t equals 0, the circuit is as shown as figure B. So it is like this. So after t equal to 0, it is like this. So V of t equal to 100 volts applied. So T is closed here. T after t equal to 0, it is closed. So 2 ohms is closed here. 2 ohms resistance is there. 1 Henry inductance is there. 0.2 farad capacitor is there. Okay. So this is after t equal to 0. So now we will apply, this is a closed loop circuit. So we will apply KVL to the above circuit. So V of t is equal to 2 into I of t plus d by dt of I of t plus 1 by 0.2 into integral I of t into dt. So 1 by c. 1 by c into integral I of t dt. Okay. Apply Laplace transform on both sides of the equation 1. We will get Vi of s equal V of s equal to 2 into I of s plus s into I of s. Okay. S into I of s minus I of 0 plus 1 by 0.2 s into I of s plus 0.2 V of 0. 0.2 into V of 0. Okay. So V of 0 is 0 anyhow, and I of 0 is also 0 with initial conditions. Since initial conditions of the circuit is 0, so I of 0 and V of 0 will become 0. So equation 2 can be written as V of s equal to into I of s plus SIS plus I of s by 0.2 into s. Therefore, V of s by I of s equal to 2 plus s plus 1 by 0.2 s, or I of s by V of s equal to 1 by 2 plus s plus 1 by 0.2 s. But I of s by V of s is nothing but h of s. So it is a transfer function of the circuit. So I of s by V of s equal to h of s, so that it will become 1 by 2 plus s plus 5 by s, or it is s by 2s plus s square plus 5, or s by s square plus 2s plus 5. This is equation number 3. From figure B, the function v of t can be obtained as v of t equal to 100 into u of t. apply Laplace transform on both sides, we get V of s equal to 100 into 1 by s. Okay, so that is 100 by s. So I of s by V of s is h of s, or I of s equal to V of s into h of s. So I of equal to inverse Laplace transform of h of s into V of s. So inverse Laplace transform of h of s is what is h of s value? That is s by s square plus 2s plus 5, and V of s is 100 by 5. So s and s gets cancelled, so that it will become 100 by s square plus 2s plus 5, or it is inverse Laplace transform 100 by s plus 1 whole square plus 4. So that is 50 into 2 by s plus 1 whole square plus 2 square. It is in the form of a by s plus 1 whole square plus a square, whose inverse transform is e power minus bt into sin ut. So it is nothing but 50 into e power minus at, e power minus 1 into 3 into sin 2t. Okay, so it is therefore I of t equal to 50 into e power minus t sin 2t, 50 into e power minus t sin 2t. Okay, so like this we can find out this I of t value. Okay, next one is the signal f of t equal to 2 pi by omega into delta of t minus sa into omega t by 2 is applied at the input terminals of the ideal low pass filter. The transfer function of such filter is given by h of j omega, h of j omega, so k into g into w of omega into e power minus j omega t naught. Find the response. Find its response. Okay, what is the given signal? Given signal is f of t equal to 2 pi by omega into delta of t minus sa into omega t by 2. Okay, what is the transfer function here? H of j omega equal to k into g into w of omega into e power minus j omega t naught, where g into w of omega is gate function. So it is defined as 1 for minus 1 by 2 is less than or equal to omega is less than or equal to 1 by 2, and is equal to 0 elsewhere. So it exists from minus 1 by 2 to plus 1 by 2. So from minus 1 by 2 to plus 1 by 2, its amplitude value is 1. Okay, so that is the gate function. Okay, let y of t is the response of the filter, then y of t, will become y of t equal to f of t converted with h of t, f of t converted with h of t. So y of j omega is equal to f of j omega into h of j omega. So convolution in time domain will become simple multiplication in frequency domain. So that is y of j omega is equal to f of j omega into h of j omega. That is that we consider as equation number 1. Fourier transform of f of t, that is f of j omega is equal to Fourier transform of f of t, that is integral minus infinity to infinity. What is f of t? What is f of t given? That is 2 pi by omega into delta of t minus sa into omega t by 2. Okay, so 2 pi by omega and delta of t e power minus j omega t dt minus integral minus infinity to infinity sa into omega t by 2 into e power minus j omega t dt. Right? Okay, f of j omega equal to 2 pi by omega into integral minus infinity infinity of t e power minus j omega t dt. So that is at t equal to 0, its impulse function, unit impulse function, its value is 1. So that it will become 1, 2 pi by omega into 1 minus integral minus infinity to infinity. This is sa of omega t by 20 power minus j omega t dt can be written as a sin omega t by 2 by omega t by 2 into e power minus j omega t dt. Okay, so we know that Fourier transform of rectangular function of t by tau is equal to sin omega tau by 2 by omega tau by 2. Okay. Now that Fourier transform of rectangle of t by tau is equal to sin omega tau by 2 by omega tau by 2. Then by dual property we have Fourier transform of sin 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 theta by 2 by tau t by 2 is equal to 2 pi into rectangular of omega by tau. 2 pi into rectangular of omega by tau. Here tau equal to omega and rectangular of x is equal to gate function, that is g of x. Then j omega is equal to 2 pi by omega minus 2 pi into g of omega by w. Okay. So f of j omega equal to 2 pi by omega minus 2 pi into g of w by j of omega by w. Okay. So g of omega by w and omega. So this is the response. Okay. Now using equation number 1, I of j omega equal to 2 pi by omega minus 2 pi g into omega by w by omega into kg into w of omega into e power minus j omega t naught. By using the inverse everyone's Fourier transform, y of t equal to 1 by 2 pi integral minus infinity into y of j omega into e power j omega t omega. Okay, so we have omega j omega is already there. That is 1 by 2 pi into that value. Okay, okay, so that it will become integral minus infinity infinity k by omega into g of w of omega into j omega t naught into e power j omega t t omega minus integral minus infinity into kg into w of omega into g of w by omega into e power minus j omega into e power j omega t t omega. That is equation number 2. Okay, solution of first term of equation 2 is here we are applying time shifting property, so that y of t will become 1 by 2 pi integral minus infinity infinity 2 pi k by omega into g of w of omega into e power minus j omega t naught into e power j omega t d omega. Okay, so that will become y of t is equal to 2 pi k by omega into g of t minus t naught. Okay, y of t equal to 2 pi k by omega into g of t minus t naught. So equation number 3. So in the next class we will do the remaining cases. Okay, y of t up to y of t it will be calculated. Okay, so for these cases, if omega is 1, if omega is greater than 1, if omega is less than 1, what will happen? We will see in the next class. With this, I am concluding the today's class.